All right, so benzene, even though it has carbon to carbon double bond, it does not react like an alkene. Just bear that in mind. All right, that means it will not react with potassium permanganate. It will not react with bromine, just like that. So the two reactions for benzene that we need to know the halogenation, and in this syllabus, it asks for bromination specifically. All right, so if you have bromine, I'm doing the equation first, then the mechanism. If you have benzene and you want to react it with bromine, you are going to use a catalyst. The catalyst is FeBr3. And you will get a bromine attached to it. All right, so that's for the halogenation of benzene. The second one is the nitration of benzene. So if you want to nitrate benzene, you react it with nitric acid and sulfuric acid. An arrow. At a temperature of about 50 to 55 degrees Celsius, and you will get nitrobenzene.
Or 60 degrees Celsius, right?
Depending on which textbook, you will see anywhere from 50 to 60.
Okay.
Yeah. Anywhere from 50 to 60, depending on your source. Right, so this will be the equation, all right? So benzene with bromine, the catalyst, so FeBr3, that is your catalyst. So unlike an alkene where you would just add it, you get a reaction for benzene, that will not happen unless you have the catalyst. All right, so these mechanism, all right, so first the name of it. Name of the mechanism, electrophilic.
Yeah, come here.
When you're doing the mechanism, you cannot use this circle. All right, you see with this reaction, there will be a precursor step, right? where the bromine reacts with FeBr3, but that part is not a part of the mechanism. It starts when your Br2 is attached to the FeBr3. All right. The first thing that happens is that your double bond here, and you can choose, right? But typically, use the one at the front. So if you put it here, this one will do it. You just draw your benzene. You have a FeBr3 that is bonded to your Br2 molecule. This one will develop a slightly positive charge. All right. So just put a positive charge on it. Once that is done, just like with alkenes, once you have the double bond, it will attack this. All right. It is basically removing the bromine from this complex. All right. Remember, whenever you're moving a pair of electron, you must use curved arrows. Remember, in reaction mechanism, you have curved arrows and you have fish hook. When you're moving a pair of electrons, it's the curved arrow. And you start from where the electrons are. So we're moving a pair of electron from the double bond to this bromine. So that is why you have the movement like that. All right. So at the end of this arrow, what you would have now, if you look, we used this pair of electron from the double bond. That means it is broken. And what you will have now is the bromine attached to the carbon. All right. These two bonds, they will stay in place. All right. So FeBr3 plus this bromine here, we just write FeBr4. It's a total of 4 bromine atoms that are bonded to it. So again, benzene removes the bromine from this complex. Once it does that, the double bond, it is broken because we use the pair of electron to get this bromine atom on the ring.
Sir, can you run through that again, please?
All right, so the bromine as the one of the double bond on your benzene ring, you are going to use it to remove the bromine atom. Once you do that, the double bond is broken. It no longer exists. So for example, if this is your double bond, right? It means you have 4 pair of electrons. You used 1 pair of them to take the bromine. So it is no longer in existence. All right. So you're only left with a single bond. So from here to here, you cannot have a double bond again. It was broken to form a bond with bromine. Understand? All right. So let's continue.
Yes, sir, thanks.
All right. In step 2, let's put back everything as is. Double bond is here. Double bond is here. Br is here. and the hydrogen is here. Now, in some books, all right, so if I check like I am lost on the bond formation with bromine and hydrogen. Let me finish first and then I will do a simpler. I will jot the carbons and do it quickly and you will see it. Now, in some textbooks, so if you look at the study guide, when I read step 2, we will just show this, where you move the electrons. Give me a second. All right, so the electrons from the hydrogen will go back into the ring. All right. But the reason why that is happening is because one of the bromine from here is going to remove it. If you remember a catalyst, it is always regenerated at the end of a reaction. If FeBr3 is the catalyst, that means at the end of the reaction, we must get it back. So the bromine atom here, it is going to remove this hydrogen. And the bond between the carbon here and the hydrogen, it is broken with the electrons going back inside of the ring. So let's go up to step 1. The double bond was here. When it took up the bromine, it was broken. It looks like this structure. Now in step 2, what we are doing is reforming the double bond. To reform it, we need a pair of electrons inside. That pair of electron, it is coming from this bond here. Remember, in a curved arrow, it is showing the movement of 2 electrons. The 2 electrons in this bond is coming back here. All right. The bromine is removing this hydrogen. If you would do that, what you will end up with now is that the ring is going to be reformed again or completed back with the set of pi electrons. And the bromine is still on it. You get that plus HBr. Because remember, the bromine, it took off a hydrogen. All right. Plus, you get back your catalyst, which is FeBr3. So this mechanism, it's just 2 steps. Sorry, oh, it's FeBr3. No, and not FeBr4. Just, hold on, where's the marker? So right here, we have FeBr4. This bromine comes off. So this bond is broken. The bond between this bromine and this Fe, it is broken. So this bromine combined with hydrogen. So let's do it again. This bond between this carbon and this hydrogen, it is broken. All right. So this hydrogen is no longer attached to the carbon. It is now with bromine. This bromine is no longer with Fe. You have the benzene, so you have bromobenzene, you have HBr, and you have FeBr3. So that is why we know longer of FeBr4. All right, what I'm going to do, I'm going to draw this structure of benzene with the carbons. so you can see it. All right. I'm going to do it again, but I'm not going to, hold on. Let me just undo that and take a screenshot if you did not have it. All right, so just take a screenshot of the board. Yes, this is what you will draw. Right? But I'm going to do a different version where you can see the carbons clearly so you can understand what is happening. Okay. All right. So benzene, the formula for benzene is C6H6. All right. So carbon, 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 and the carbon is there. All right. So double bond, double bond, double bond. You have a hydrogen here, hydrogen here. Remember, every carbon atom must have 4 bonds. All right. So that is benzene without the skeletal formula. All right. So everything is clear now. All right. Let me erase the other side of the board. All right. So as we said, right, you have the Br. Have Br here. Good. With the positive charge on it. So that's the electrophile. You see this line here. Let me move it.
Sir, I think an age is missing. Someone said it in the chat.
Oh, thanks. Yeah. I'm up here, right?
Okay.
Yes, thank you. All right. So this black line here, I am using it to represent the pi electrons in your double bond. So this line here, it has 2 electrons, and I am using it to form a bond with this bromine. So this is a dative covalent bond where one atom donates 2 electrons to form the bond. So we are moving the 2 electrons from this bond to bromine. That means the double bond is broken. All right. The double bond is broken. You only have a single bond. And now we have the bromine attached to it. So we are forming a bond between the carbon and bromine. At the end of the process, bromine is attached. You still have the hydrogen there as well. Is it clear now as to what happened?
Yes, sir. Thanks.
All right, so let's just complete the ring. Put back the double bond here, double bond here. Single bond is going to be there. Which is here. Oh, I forgot to do something as well. This carbon here, right? How many bonds are around it?
3, sir.
3. So once it has 3, put a plus charge on it. All right. So in the second step now, what did we do? We have Br, right, attached to Fe, Br3. A lone pair of electron now is going to remove this hydrogen. When it removes this hydrogen, the two electrons that were here, we're going to put it here. So you get back the double bond. Is that clear? Basically moving the electrons from here to here. That is how you get the double bond. And the positive charge will disappear. Is that clear?
And then that forms HBr.
That is correct. So, hold on, what just happened? Right. So this bond is broken, this bond is broken as well. That is why you get HBr, FeBr3, and bromobenzene. No, sir. Destiny, you want to ask aloud so I can help quickly? All right, if you miss it here, let's do nitration of benzene because I'm going to do but the same thing again, 2 steps. All right, I'm going to do it again with nitration of benzene. All you're doing for when you're adding something to benzene, all you're doing using a double bond to take up an electrophile. Good. And in the second step, you take off a hydrogen. That's it. Two things only. You're going to take up an electrophile. When you take up the electrophile, the double bond is going to be broken, as I saw here. The second thing that needs to happen is that we need to put back the double bond. To do that, we break a carbon to hydrogen bond. That's the mechanism. You take up an electrophile by breaking a double bond. You reform the double bond by removing a hydrogen. I can repeat. All right, so let me put a statement as to what happened. See if that can help. All right, so that is what basically happened. If you look at what step 1 says, one of the carbon to carbon double bond is used to form a bond with bromine. This converts carbon to carbon double bond to carbon single bond. Have a carbon to carbon double bond here. We used it to form a bond with bromine. When that happened, carbon to carbon double bond was converted to carbon single bond. All right. Then step 2 says to reform the carbon to carbon double bond, a hydrogen atom is removed from a carbon to hydrogen bond. And those electrons are used to reform the carbon to carbon double bond. So here you clearly see we are removing a hydrogen atom from the carbon to hydrogen bond. The electrons in that bond are used to reform the double bond. So those are the two things that happened.